All right, guys. This is graph 2. For graph 2, we're going to look at the quadratic graph, and more particular, we'll be looking at the positive x squared graph. All right. I started by saying that y is equal to ax squared plus bx plus c is the general format of a quadratic function. All right. So in a quadratic function, you must have at least a term in x squared. You may have a term in x, and you may have a constant term, but you must have at least a term in x squared. Now, the graph of a quadratic function is a smooth curve called a parabola. All right, we'll have a look at that curve. Um, as indicated before, y is equal to ax squared plus bx, and y is equal to ax squared plus c are other forms of a quadratic function. So y is equal to ax squared plus bx is a quadratic function in which that has no what constant term. Y is equal to ax squared plus c is a quadratic function that has no term in x. But one thing a quadratic function must have is a term in x squared. So in a quadratic function, the highest power of the unknown x is 2. All right. This is notes on just some notes on a positive x squared graph. All right. So this is an example of a positive x squared graph. It is a sketch of a graph of a quadratic function in which the number in front of x squared is positive. All right. Here are some properties. The number in front of x squared is positive. So for the graph to have this shape, the number in front of x squared here, that number in front of x squared, a must be positive. So right now we're talking about something in general, we use what letters, but here being more specific, we'd be using actual numbers. So a is representing a number. And for the graph to look like this, that number a must be positive. So c from y is equal to ax squared plus bx plus c, c, that number at the end of the quadratic function, the constant, is the y-intercept. So here we have the y-intercept. The y-intercept is simply where the graph cuts the y-axis. So this is the y-intercept. The y-intercept is the value of y where the graph cuts the y-axis. All right, and that is represented by c. So the y-axis, which is the line x, is equal to 0. So the x value is 0, the y value is c. 0, c are the coordinates of the y-intercept. Um, for a positive x squared graph, there's a minimum turning point, or there's a minimum point on the graph right there. That point is called the minimum turning point. That point is called the minimum turning point. And p, so x is equal to p, x is equal to p, y is equal to q. So x is p, y is q. Vertical p, horizontal q are the coordinates of the minimum turning point. All right. What are properties? Y is equal to q is the minimum value of y is equal to ax squared plus bx plus c. All right. So remember that the curve here, the parabola here is the graph of y is equal to ax squared plus y is equal to ax squared plus bx plus c. And that parabola, the lowest point of that parabola, the lowest point is here. So the lowest value of y, or the lowest value of y on this graph, is y is equal to q. So y is equal to q is the minimum value of y. X is equal to p is the value of x at the point on the graph where y is a minimum. So this is the point on the graph where y is a minimum. and the minimum value of y is equal to q. Now, at this point in the graph where y is equal to a minimum, the value of x is equal to p. So x is equal to p is the value of x at the point on the graph where y is a minimum. What else? X is equal to p is the equation of the axis of symmetry, um, which is the same as saying the equation of the line of symmetry. So now, so here, this is the line x is equal to p, and this line is the line of symmetry. All right. What is the line of symmetry? The line of symmetry is a vertical line that passes through the turning point. The line of symmetry is a vertical line that passes through the turning point. Now all vertical lines are x lines. So x is equal to p is the equation of the line of symmetry. All right, let's just remember about this. All right, so x is equal to p is the equation of the line of symmetry. All right, x is equal to alpha and x is equal to beta are the x-intercepts are the roots of ax squared plus bx plus c. So x is equal to alpha, which is here. X is equal to alpha, which is here, and x is equal to beta, which is here. Those are the roots of the function ax squared plus bx plus c. All right. Please note that if you have a graph of the function, the roots are the x-intercepts. So alpha here is an x-intercept, and beta here is the x-intercept. What is an x-intercept? The x-intercept is the value of x where the graph cuts the x-axis. So x is equal to alpha and x is equal to beta are the roots of the function ax squared plus bx plus c. Now, obviously, we're talking about this thing in general. And when we talk about something in general, we're using what letters. When you do an actual question, you'll actually be dealing with actual numbers. All right, so we'll get to that shortly. All right. So, what is the roots of a quadratic equation or of a quadratic function? So the roots of ax squared plus bx plus c are the values of x for which ax squared plus bx plus c is equal to 0. On a graph of y is equal to ax squared plus bx plus c, in other words, on a graph of the function, the roots of the function are the x-intercepts. So as we show in this diagram here, on a graph of the function, the roots of the function are the x-intercepts, which is here and here, where the graph cuts the x-axis. All right, let's have a look at a question. This is example 1. So this graph is already drawn, and all we're doing is attempting to answer some questions based on what we just did. So the diagram above is the graph of y is equal to x squared minus 2x minus 3. So this is the graph of y is equal to x squared minus 2x minus 3. That's the first thing. That's the graph we're looking at. We're asked to determine the coordinates of the minimum turning point. Min TP stands for minimum turning point. We're asked to determine the minimum value of the function. So the minimum value of the function is the minimum value of y on the graph. The value of x for which y is a minimum, and the equation of the line of symmetry, and we're asked to determine the roots of the function. All right, so let's just turn the page to answer the questions. All right, first of all, right here is the lowest point on the graph. All right, so the lowest point on the graph is the minimum turning point. All right, and the x coordinate here is 1, and the y coordinate is -4. So 1 -4 are the coordinates of the minimum turning point. 1 -4 are the coordinates of the minimum turning point. All right. All right. Number 2. What is the minimum value of y? The minimum value of y is, all right, so the minimum value of y is another way of saying the value of y at the lowest point on the graph. All right, so to answer that, I'm going to draw a line down here at the lowest point on the graph. This is where it cuts the y-axis. All right, let's do something to straighten up this line a little. Technology. All right, this is painful. Ah, got it. So just straighten up this line a little. All right, so we're asked to find the minimum value of the function, or which is the minimum value of y, and the minimum value of y is the value of y at the lowest point on the graph. So this is y is equal to -4. That's the minimum value of y. So the minimum value of y is equal to -4. All right, so you get the minimum value here. Now, the minimum value, we're asked now, what is the value of x for which y is a minimum? So the minimum, y is a minimum at the minimum turning point. So y is a minimum at the minimum turning point, which is right there. Let's circle it. Now, every point in a graph of an x coordinate and a y coordinate, the y coordinate is -4, and the x coordinate is, all right, straighten up this a bit. All right, this is the x coordinate, and this is x is equal to 1. So x is equal to 1 is the value of x for which y is a minimum. In other words, at the point on the graph where y is a minimum, which is here, the value of x is 1. We're asked to find the equation of the axis of symmetry. Remember I said to you that the axis of symmetry is a vertical line that passes through the turning point. So this is the line of symmetry. The line of symmetry. All right. All right. It's the line of symmetry. All right. So, and there's a vertical line. So it's x is equal to what? 1. Remember, all vertical lines are x lines. So x is equal to 1 is the equation of the axis of symmetry. Um, we're asked to determine the roots. Remember, if you're if you have a graph of a function, the roots of the function would be the x-intercepts. So my x-intercepts would be x is equal to -1 and x is equal to 3 are the roots of x squared minus 2x minus 3. All right. So that is us answering those generic questions. We're answering, these questions about a graph that we just looked at in general, but now we're looking at a more specific case of it. All right. So next we're going to draw a graph. We're told given y is equal to x squared minus 4x plus 2, we're asked to copy and complete the table. All right, the table here is what you call a table of values. It's called a table of values, and the table of values consists of what it consists of x values and y values. All right, it consists of corresponding values of x and y coming from what the same equation. All right, so two of the values of y is missing, and the first thing you have to do is to complete the table. All right, so to get the value of y, you have to use the equation. So the equation says y is equal to x squared minus 4x plus 2. So the value of y when x is 2 is missing. So I'm going to say when x is 2, y would be equal to 2 squared minus 4 times 2 plus 2. 2 squared is 4 minus 8 plus 2. All right. 4 minus 8 is minus 4. Minus 4 plus 2 is minus 2. So when x is 2, y is minus 2. All right. So let's do this again because we still have one other missing y value. Y is equal to x squared minus 4x plus 2. I'm going to say when x is equal to 4, y would be 4 squared minus 4 times 4 plus 2. 4 squared would be 16 minus 4 times 4, which is what? 16 plus 2. So y here would be 2. All right. So the missing value of what y there would be 2. So we completed the table. Then we're asked using a scale of 2 centimeters to represent 1 unit on the x-axis and a scale of 1 centimeter to represent 1 unit on the y-axis. Draw the graph of y is equal to x squared minus 4x plus 2 for values of x between minus 1 and what? 5 inclusive. All right, so we're asked to draw the graph. So let us prepare our graph sheet. First thing you need to do before you draw a graph is to prepare a graph sheet. So preparing a graph sheet means that you're going to have to put in your axes, and you're going to have to put in and label your axes. So the first thing we want to do is put in the y-axis. All right, so what's going to help us to do that are the values of x. So the values of x tells you, where gives you an idea as to where to position your y-axis. All right, so this graph goes as the furthest this graph goes left is to -1, and the furthest that the graph goes right is +5. So obviously I'm going to need more space on the right hand side of the graph where x is positive, more than the left hand side of the graph where x is negative. So let's put in our axes. All right, it's 2 centimeters to 1 unit, and this graph goes as far as -1. So I would need at least 2 centimeters to the left, because it's 2 centimeters to 1, and to the left the graph only goes to 1. All right, let's increase the thick. All right, so let's draw my vertical axis. I will put my vertical axis around here. It's my vertical axis, which is my y-axis. Straighten this line. So obviously you're gonna, for you to, when you draw this, you must use a ruler. All right, so we'll put in our vertical axis. Let's label it. Our vertical axis is our y-axis. Let's put in a horizontal axis. Again, go back to the table of values to get a rough idea as to where to put it. This graph goes as high as what? +7, and as low, the highest it goes is what? +7, and the lowest it goes is negative what? 1. So the values of y help me to position my x-axis. So I need more space to the what? Top where y is positive, and less space to the bottom where y is negative. All right, since I need at least 2 centimeters, let's go up what? Maybe 3 or 4? 1, 2, 3. Right, let's go up 4. So from the bottom, 0, 1, 2, 3, 4 centimeters. Draw my x-axis on this line. All right, remember, whenever you're drawing the axes, you must use a ruler. That's 1. 2, you must always draw your axes on major grid lines. So in my diagram, the major grid lines are the red lines and the black lines, and the minor grid lines are the blue lines. All right, this is the origin. So next thing we need to do, so the first thing we have done is what? Aligned our axes. One common error that people sometimes make is that people, you must resist the temptation to put the axes in the middle. Um, at lower school, I'm guessing, and when persons did graph, people just automatically put the axes in the middle. At this level, you need to apply some form of know-how, some knowledge, or some form of strategy, some form of thinking to where you put your axes. All right, so let's label the axes next. The scale says 2 centimeters to 1 unit on the x-axis. So on the x-axis, every 2 centimeters, the number goes up by 1. 1 centimeter, 2 centimeter. So I'm going to put 1 here. 1 centimeter, 2 centimeter, 2 here. 1 centimeter, 2 centimeter, 3 here. 1 centimeter, 2 centimeter, 4. 1 centimeter, 2 centimeter, 5. Over here, 1 centimeter, 2 centimeter, -1. So on the y-axis, the label is 1 centimeter to 1 unit. So here it is from the scale, 1 centimeter to 1 unit on the y-axis. So on the y-axis, every centimeter, the number goes up by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Down here, -1, -2, -3, -4. All right. So we'll label our axes. Now we're ready to plot our points. First point is -1, -7. Sorry, -1, 7. So -1 vertical and 7 horizontal. All right. So obviously that point is there. So the point is here. -1 vertical and 7 horizontal. All right. That's the point. All right. So remember, you need to indicate your points carefully. All right. And that's what I just did. The next point is 0, 2. So the y-axis is the line x is equal to 0, 0, 2 would put me here. vertical 0, horizontal 2. The next point is 1 minus 1. So the next point is 1 minus 1, which would put me about here. So it's 1 minus 1, that puts me there. The next point is 2 minus 2. So it's 2 vertical minus 2 horizontal. That puts me here. 2 vertical minus 2 horizontal. That puts me there. I'm guessing the next point would be 3, 1, which is here. Then 4, 2, which would be here. And lastly, 5, 7. So that's 5 vertical, 7 horizontal. That will be here. That will be here. 5 vertical, 7 horizontal. All right. All right. Once you have all the points, then the next thing you need to do is that you need to what? Draw your curve. Curve must be drawn with by freehand. One, the parabola is a smooth curve, so you need to take care to ensure your curve is smooth. One way to achieve that is that when you're drawing a curve, you try and draw through as many points as possible with every movement of your pen. All right. So this thing will take some amount of practice. So you need to draw as many graphs as possible. All right. So let's see what we can do here. Hope this works the best that I can. All right. Sometimes you just gotta, if at first you don't succeed, you have to watch, try again. All right, that's the first half. Let's go for the second half. All right, that's the second half of my curve. And as I said to you, the curve must be drawn by freehand. After you draw your curve, you need to label the curve. So this is the graph of y is equal to x squared minus 4x plus 2. All right, let's do it again because I need to label the graph on the graph. All right, I can't have the labeling coming off the graph. All right, so this is the graph of y is equal to x squared minus 4x plus 2. All right, so this is an example of a positive x squared graph. And by positive x squared, I mean that the number in front of x squared, the coefficient of x squared is positive. All right, here's a question in which the graph has already been drawn. And we're going to use the graph to answer some questions. All right, so the first question says, the graph below represents the function f of x is equal to x squared minus 3x minus 2. We're asked to use the graph to determine a, the value of f of x when x is 2. In other words, what the examiner is saying is, what is the value of y when x is 2? Or at the point on the graph where x is 2, what is the value of y? All right, so let's go here where it's a little bit bigger. So I'm going to give my answer to start up my answer for A. So I'm going to say when x is 2, f of x is equal to, well, let's find out. First of all, this is here is where x is 2. So let's identify the point on the graph where x is 2. So from here, use your ruler and you draw a straight line down until it reaches the graph. So this is the point on the graph where x is 2. To find out the corresponding value of y, from that point you're going to draw a horizontal graph, horizontal line until it reaches the y-axis. All right, so let's see what I'm seeing here. Where this look to me is like, if x is, that's 4, 2, 4, so that must be 5. So when x is 2, f of x is equal to minus 5. Let's write that over. When x is 2, f of x is equal to minus 5. That's the first answer. The second answer, but here's a good question. Do I need to draw these lines to answer the questions? Yes, but you don't need to circle anything. So there's no need for this circle here, nor for this one here, nor for not even for this one here either. All right, but do you draw lines to answer graph? Yes. No. B, to answer questions about the graph? Yes, you do. You must never draw lines to plot a point, but you should draw graphs, lines to answer questions. Question number 2 says the value of f of x when x is minus 1.5. So in other words, this is asking what is the value of y at the point on the graph where x is minus 1.5. This is minus 1 and this is minus 2. So here is the point. This is minus 1.5. Draw up until it reaches the graph. When it reaches the graph, you stop. And then you draw a horizontal line. All right. So for my answer, I'm going to say when x is minus 1.5, f of x is equal to, all right, let's see if we can get some ideas from that. All right, so this is 3 here, 4. All right. So this is 1 centimeter on the graph. This is 1 centimeter, and 1 centimeter is divided into 5. If you divide 1 by 5, you get 0.2. Every centimeter on your graph is divided into 5 equal parts. Every centimeter is divided into 5 equal parts. And since this is 1 unit, 1 centimeter is representing 1 unit. When you divide 1 by 5, you get 0.2. So this is 3. This would be 3.2, 3.4, and this here would be 3.6. So my answer would be when x is minus 1.5, f of x or y would be 3.6. All right, next question. The value of x for which f of x is equal to 0. So in other words, what you're being asked is what is the value of x at the point on the graph where y is 0? First of all, this is the line y is equal to 0. The x-axis is the line y is equal to 0. On a graph, all your vertical lines are x lines and all your horizontal lines are y lines. All right. So what we're looking for, what we want is what is the value of x at the point on the graph where y is 0? So this is the point on the graph where y is 0 and the point on the graph where y is 0. Let's determine the value of x. So to answer, I'm going to say C. When f of x is equal to 0, x is equal to, so let's figure it out. Let's enlarge it so we can see it a little better. At least I can see it. So first of all, this is 2 centimeters on the graph. Remember, every centimeter is divided into 5 equal parts. So 2 centimeter on the x-axis, which represents 1 unit, will be divided into 10. And if we divide 1 by 10, each part would be 0.1, because 1 divided by 10 is 0.1. So this would be 3, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7. This would be 3.8. So one of my values would be 3.8. When f of x is 0, y is what? Sorry, when f of x is 0, x is 3.8. Let's get the other answer. The other answer would be here. All right, so it don't reach 1 yet, so it's 0. Remember, each smaller division is 0.1. So this would be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. This would be 0.8. So when f of x is 0, x is equal to 3.8, and x is equal to minus 0.8. All right, more questions? The value of x at which f of x, the value of x, B says the minimum value of f of x. All right. So first of all, the minimum value of f of x, this is a graph of f of x. All right. So the minimum value would be at the lowest point on the graph. The lowest point on the graph is here. The minimum value of f of x is another way of saying the minimum value of y, or at the lowest point on the graph. All right. So that's at the bottom there. So D, I would have f of x is equal to, so look at it. All right. First of all, we want the lowest value of y at the bottom here. The lowest value of y. So what am I observing? This is minus 4, and down here is minus 6. So here would be minus 5. That's minus 5. So the lowest point on the graph is below minus 5. All right. So each division, remember on the vertical axis is 0.2. So this would be minus 5.2. So it passes minus 5.2, but it hasn't reached minus 5.4. All right. So between 5.2 and 5.4 would be 5.3. So my answer would be f of x is equal to minus 5.3 is the minimum value of f of x. E is asking for the value of x at which f of x is a minimum. So again, f of x is minimum at the lowest point here. So to determine the x value at this point, I'm going to go up until I reach the x-axis. So use your ruler and draw a vertical line. All right. and that is in the middle between 1 and 2. So this is 1.5. X is equal to 1.5 is the value of x where f of x is a minimum. All right. So what next? The solution of the equation x squared minus 3x minus 3 is equal to 5. X squared minus 3x minus 3 is equal to 5. X squared minus 3x minus 3 is equal to 5. All right, let's do it then. All right. So we're asked to use the graph to solve the equation x squared minus 3x minus 3 is equal to 5. All right. This is a little bit different from what I was expecting, but let's do it anyway. First of all, the graph we drew is the graph of it says up the top x squared minus 3x minus 2, but it's actually x squared minus 3x minus 3. So this is an error. This is an error here. Should have been minus 3 at the end. Minus 3. All right. So how do we use graph to solve an equation? This is what I said to you. For you to use graph to solve an equation, you must draw a graph of the left-hand side of the equation, and you must draw a graph of the right-hand side of the equation. The left-hand side of the equation is y would be equal to x squared minus 3x minus 3. And the right-hand side would be y would be equal to 5. So in order for us to use graph to solve an equation, we must draw a graph of the left-hand side of the equation and draw a graph of the right-hand side of the equation. The solution would be the values of x where the two graphs intersect. Values because it's a quadratic equation. All right, so this one has already been drawn. Y is equal to x squared minus 3x minus 3. It has already been drawn. It was drawn for us by the examiner. The one that has not been drawn is y is equal to 5. All right, so let's get back to our graph and draw the line y is equal to 5. First of all, y lines are horizontal lines. So this is 4 here. We have what? 4 here and 6 here. So between 4 and 6 in the middle is 5. So let's straighten this line. So when you are drawing this line, you must ensure that you use a ruler. All right. So this is the line y is equal to 5. All right. So what we want is the solution. Remember we said that the solution are the values of x at the point of intersection. They intersect here and intersect here. What are we doing? We are using graph to solve a quadratic equation. If you're using graph to solve an equation, you must draw the graph of the left-hand side of the equation and draw the graph of the right-hand side of the equation. And the solution would be the value of x where the two graphs intersect. So let's determine the value of x. So let's come down here. The value of x here would be 4.7. Let's determine the value of x over here. The value of x over here. The value of x, I'm going down to the x-axis. It's past 1, but don't reach -2. So my answers would be, so the solution would be x is equal to -1.7 and x is equal to 4.7. Whenever you solve a quadratic equation, you must get whenever you solve a quadratic equation, you must get two answers. So, and the last part of the question asks for the interval on the domain for which f of x is less than -3. All right. So we're talking about the interval on the domain for which f of x is less than -3. All right. F of x. All right. Make it look a bit formal here. So this is g. So this is f, and now we're at g. So f of x is less than -3. Is less than -3. But f of x is actually what? X squared minus 3x minus 3 is less than -3. All right, so what we have is a quadratic inequality. You basically solve it in a similar way as the equation. You have to draw the graph of the left-hand side, which is y is equal to x squared minus 3x minus 3 already drawn. And you have to draw the graph of the right-hand side, which is y is equal to -3, not yet drawn. So let's go back to our graph. And we need to draw the line y is equal to -3. That's here. All right. Remember, you must use a ruler to draw this line. All right. So that line cuts the graph here. It cuts the graph here where x is 0. And it cuts the graph here where x is 3. All right. So we're looking for the domain values for which f of x is less than -3. All right. So in the graph here, this is the line y is equal to -3. This is f of x is equal to -3. All right. Um, this is the region on the graph that is above this line is you'd find the region of the graph where what where f of x is greater than -3, and below this line is the region of the graph where f of x is what less than what -3. So the domain values is what they're asking for, which are the x values. All right, these are the domain values. These are the domain values for the section of the graph that is below, that is less than what, for the section of the graph where f of x is what, less than -3. Between x is equal to 0 and x is equal to 3 are the values of x for which the graph is what, below, for which f of x is less than -3. So the answer here would be this. The answer here would be x is the solution of this inequality would be x is less than 3 and x is greater than was it 1? 1. Let's go back and double check. No, it's not 1, it's 0. And x is greater than 0. All right. We could write that as one inequality. That would be the inequality x is what? Less than 3, but greater than 0. So x is less than 3, but greater than 0 are the values of x for which f of x is less than minus 3. All right, this is the end of graph 2, and graph 2 is dealing with the positive x square graph. All right, one more lesson on this topic. All right, and that should be graph 3.